All right, let's get started. So today we want to talk about inheritance. Let's talk about inheritance. All right, so this is the first kind of deeper concept that we're getting into. I don't think it's too overwhelming, but it is one of the tougher concepts. That said, we already talked about recursion, so that one was pretty wild too. But the point I want to make is this is one of the first lectures where the pace really starts to slow down in the course a little bit. Most of the lectures in the first few weeks up until now, the first 5 weeks, I'm usually talking a mile a minute, just ripping through topic after topic after topic. The first 5 weeks, I feel like there's a lot of topics. There are a lot of concepts with a lot of topics in them where each one isn't too hard to understand. I mean, they're tough, don't get me wrong, especially if you're seeing them for the first time. But they come at a rapid-fire pace, and there's just a lot of them, which makes it pretty overwhelming, to be honest. This is the first topic where we finally get to slow down. You should see a noticeable change in pace during this lecture where I'm going to talk a lot slower. We're going to go at a much slower pace as we go through this topic. Because there's really one big thing that I want to talk about today, inheritance. That's what we're talking about. When we talked about objects and classes, for example, we're talking about objects, classes, constructors, methods, instance variables, references, and the heap with memory diagrams. We're introducing a lot of concepts in that week 3, was it? Yeah, week 3. Here, when we're revisiting OOP and building on our OOP knowledge, it's inheritance. I'm going to show you inheritance. Yeah, I can still break it down into topics, override, superclass, superconstructor calls, but there's just not as many things that I could even list like that. It's really one bigger topic. So with that, let's get into it. For this, we're going to teach this by example. So we're going to use an example where we'll build parts of a game. We'll simulate some functionality of a game. Note that we won't actually build this whole game. Maybe someday, some future semester, we'll end up building the whole game. But I think, honestly, even if Paul and I had the time to build out the whole thing, I think it'd be more of a distraction, not the game itself, but the amount of code that we'd have to show you to say, look, here's how you build the whole thing. Someday. We'll get something similar later in the semester. We'll get big programs. But this is what we want to build, a game that's going to have 2 items, health potions and weapons that can be used in the game, that can eventually be used by players. We'll keep it pretty simple today. We'll simulate a lot of the functionality, just kind of fake it for now. And then if you look in the repo, you can see what the code is eventually going to be. The use method is going to take an instance of a player class and then actually work with that player class. For now, we're just going to print to the screen to simulate things. So here's a HealthPotion class. It's going to have 3 instance variables. 2 for the location of the object as a double. So we're thinking of a 2D space with XY coordinates. And the health potion can be located somewhere in this space, which will be our game world. This XY location is where the health potion is actually located. And then another instance variable increase, which is the amount of health that's restored when a player consumes this potion. If you've played video games at all, this is a pretty similar concept. You drink a health potion, you restore your health. If you haven't, just very briefly, characters will have a health value. They'll have a max HP, and then some amount of HP as they take damage will be lower than their max. And then they'll drink a health potion to restore some of that HP, where HP is health points. I've realized I use game references in lecture fairly often, like each semester, thinking it's computer science, so everyone plays games. But there are some students who don't play games, so I always have to put those little explanations in there. So, because if you don't play games, this example doesn't make sense at all. But that's the idea. We'll be at some XY location, and then the health potion will increase your health by that much. And we would have some extra logic to make sure you can't go over the max HP like we did last time we saw a player class. So we're just going to print to the screen to simulate that healing effect. Great. Everyone good with this? If there are questions on this, please let me know. But I assume that we all know this stuff. We've been doing this for a while. If I gave this, this is simpler than what you did on the classes quiz already, which aside from recovery opportunities, we're all done with the classes 1 quiz, the classes 1 interview, the task 2, which was creating classes and stuff. So I assume everybody's good with this, but if not, let me know now before the content completely leaves you behind. Let me know now. What are all of our programming tasks building? It's a good question. So several different things. I guess there's no harm in spoiling it, right? What we're building. I mean, some of it you can see what it's building. I think for the most part you could guess, but a ratings app is generally what it is. Be able to give ratings and then process those ratings, so we can rate either songs or movies in these. We're also going to build degrees of separation. If you've heard what do we even call it? 6 degrees of separation from the Kevin Bacon thing. Like how far away is an actor from Kevin Bacon? Have you? Oh, I actually do want to know this. Who's heard of that? Oh my goodness, only a few of you. Well, that's what we're building in Task 9. So I was worried. So when me and Paul were designing that, I did tell him, is anyone even going to know what that is? I don't know if our students know what that is. You'll learn. You'll learn what it is, I guess, if you don't. Hopefully it's one of them things that just everybody knows, but it's so ubiquitous that you just don't want to raise your hands. It's a problem. I can never tell. Did I ask such a dumb question? Yeah, of course I know what that is. Or do you actually not know what that is? I can never tell. Y'all never give me the information, but if you don't, you'll find out what that is. But that's what we're building. All right, so no questions on this? I think I went on a tangent long enough that if anyone had questions, they'd ask them. So let's go. So today we want to talk about inheritance. We're going to further this, and instead of building that HealthPotion class the way we have been, we're going to use inheritance to build it. So with inheritance, we're going to split this up using inheritance, and let's see what this is and how this works, this new concept that we're going to talk about really all week this week. So instead of just building the HealthPotion class with all the functionality that we saw in the previous slide, we're instead going to split this into 2 separate classes, create one game item class where we're going to store some of the behavior and state and behavior of the HealthPotion class. So with this, we create game item, and in the game item class, this is where we're going to write all of the behavior that's going to be common for any item in our game, as the name implies. So we're eventually going to have HealthPotion and weapon in our game. Any code that both of those items should have is going to go in the game item class. So in game item, right now we're going to have all the location stuff. We have a constructor that takes that XY location, our instance variables that take that XY, that store the XY location, and then in HealthPotion, we're going to inherit all of that state and behavior using the keyword extends. So HealthPotion is going to extend game item, which means HealthPotion inherits game item, which means HealthPotion gets all of the state and behavior from the game item class. So anything defined in the game item class also exists in the HealthPotion class, even though that code is not explicitly written in the HealthPotion class. So we're going to inherit all that state and behavior from game item. So these 2 instance variables, X location and Y location, these variables exist in every object of type HealthPotion, even though they're not declared in the HealthPotion class. When we say extends game item, that's going to get all of the state, all of the instance variables from game item, and add them to the HealthPotion class. So now GameItem has those two instance variables in addition to its increased variable. HealthPotion will have all the same state and behavior as it did the first time we saw it when it was just one class, because it's inheriting those instance variables from GameItem. HealthPotion inherits all of the behavior from the GameItem class as well. So all of the methods, for now it's just the one constructor from GameItem. We get the constructor, but we get any methods that are defined in GameItem as well when we extend GameItem or when we inherit from GameItem. So this is class HealthPotion, that's all this code, and also inherit all of this code. So all of this code exists in the HealthPotion class. A little bit of vocab with this. We say that the GameItem class is the superclass of HealthPotion, or a different set of terminology, the parent class. So GameItem is the parent class of HealthPotion, or GameItem is the superclass of HealthPotion. I'll stick with superclass when I say that. And omitted from the slide, for whatever reason when I made this slide, I couldn't think of it. But then in the other lecture, somebody's like, where's a subclass? HealthPotion, the other way around, we say HealthPotion is a child class of GameItem, or HealthPotion is a subclass of GameItem. So a little terminology, I'll usually stick with superclass and child class, but parent class and subclass are also referring to the same thing. Yeah. No. So the question: can GameItem access access? Oh my goodness! Can GameItem access instance variables of HealthPotion? No. So GameItem isn't aware that the code itself isn't aware that HealthPotion is extending it. It only knows about its own stuff. So this is a one-way relationship. HealthPotion knows all about GameItem. The GameItem knows absolutely nothing about HealthPotion. The other way around, can HealthPotion access the instance variables of GameItem? Sort of. If we go the other way around, sort of. I have these as private variables. This is something we'll have a bigger conversation about in a future lecture. But these are private instance variables. With private, those variables can only be accessed within the class itself. And that includes child classes. HealthPotion can't access these variables directly because they are private. Any code outside of the GameItem class can't access these instance variables. So we would have to have getters and setters to work with those variables. Yeah?
If HealthPotion became a parent class, comes from it also inherit?
I want to say yes, but can you repeat that one more time? So I make sure I got it all straight.
If HealthPotion became a parent class and a subclass, would GameItem also extend to that subclass then?
Yes. So if I had like Super HealthPotion extends HealthPotion, and HealthPotion extends GameItem, then our Super HealthPotion would indirectly extend GameItem, and Super HealthPotion would have all of the state and behavior of GameItem. Yeah.
What's the point of making a different?
Good.
Like, why not just have it in the same class?
It's a good question. It's an excellent question. It's a great question. We'll just leave it at that, right? I do have answers for that, but they're in a couple of slides. So the big answer is sharing code. I'll spoil some of it right here. When we introduce weapon also, weapon is also going to extend GameItem, and then weapon and HealthPotion both get all the state and behavior of GameItem. So when we write the code once in GameItem, and both classes get that state and behavior. That's the big advantage of this. So right now, what's on screen, you would never do this because it's dumb. But once we have multiple classes extending the same class, then it gets more powerful. Before we get to a deeper answer on that, we got to call the superclass constructor. So whenever you have inheritance, the constructor of the child class has to call the superclass constructor. You have to. When you create an object of type health potion, there's no getting around it. The superclass constructor, the game item constructor, a game item constructor, has to be called. Period. That's it. It has to be. Absolutely has to be. We can do that by using the keyword super, which is similar, somewhat similar to this, but quite a bit different as well. Super is going to be the super class. So if we want to access anything of the super class, super, the keyword, is in place of game item. So if we want to call something, if we want to access something of the super class, we use the keyword super. In this case, we're calling the constructor. So super is in place of game item. We're calling the constructor. But we're not saying new to call the constructor because we're not creating a new object. We're just calling I shouldn't say just, but we're calling two constructors to create a single health potion. But the health potion constructor has to call its superclass constructor. So we do that using the keyword super and calling that superclass constructor like that. Some of you might be saying, well, I've coded in Java before. I used inheritance, and I didn't have no superconstructor call. And you're absolutely right. But the class, the subclass, the child class always has to call the superclass constructor. But there's a special situation here where that call can be implicit. So you don't have to actually write the code for it if the superclass has a constructor that doesn't take any parameters. So if you have a constructor that takes no parameters, you don't have to type super, open paren, close paren, semicolon. You don't have to physically type that out. But that line of code is effectively still there. It's just automatically called by Java. So this code is still, this health potion constructor still calls the game item constructor, but we don't have to type it explicitly if the constructor takes no parameters. But if the constructor does take any parameters at all, you have to call the superclass constructor explicitly because Java's not going to automatically guess what arguments you want to pass to those parameters. So we do have to call it explicitly if there are parameters in the constructor. If we have no explicit call and the superclass has a no parameter constructor, then we can omit the super call in our code, but it still exists. It still is being called. It will still be called. So that's the only reason you can actually see, might see code that doesn't have the superclass constructor. It's still there, it still happens. So if you see code like this and you're tracing a memory diagram, I don't think we'll get this tricky on the quizzes, but if you see a memory diagram where you have this code that you're tracing, don't forget your superclass constructor stack frame. It has to still be there. It's still called. It's absolutely still called. How would inheritance be different from just a regular import? So the inheriting class actually gets the instance variables and behavior as part of its definition, as if we wrote the code inside this class. When we import something, we have access to that class, and we can create instances of that class. We can do all the regular things, access its static members and its static methods, but we don't just gain the behavior from it as part of the definition of our class. I don't know if that's the most satisfying answer I can give, but that one's hard to explain until we get to polymorphism. I'll have a better answer for that one. Yeah. If you called game item, good question. I had a few good questions last time where I had to hop over to IntelliJ. Somebody was asking about inner classes, so I built this. Let's find out. Go to a health potion, because I actually don't know the answer to that one. If I actually did game item instead of using super, no, it doesn't let me. I was hopeful for that one that it would, but I guess we have to say super explicitly. Is health potions constructor using the instance variables from game item? I'm not 100% sure how to answer that one. Is the health potion constructor using the instance variables of game item? It's taking these inputs and passing them as arguments into the game item constructor. It's not accessing the instance variables directly, though. So it's not using those instance variables directly. The HealthPotion object that's being created will have instance variables X location and Y location, though. Hopefully that somewhere in there I answered that question. Yes. If there's multiple constructors, so super, like with this syntax, always calls the constructor. If there are multiple constructors, they have to have different parameter lists. So based on the arguments that you give it, it would use that to determine which one to call. Like if I had a second constructor that takes no parameters, this one would call the one with the 2 parameters. If I had another one that took 2 parameters, but they were both strings, it would see that I'm passing 2 doubles and call the one with 2 doubles. So it depends on the types of the arguments. Okay, but why? Why would we do this? I got the foreshadow this already, but let's get into the whole discussion of it. Why the hell would we do this? What's on screen right now, you wouldn't do that. It's just dumb. There's I can kind of see a potential debate here where you're separating your location code from the rest of your code. Maybe somebody could make that debate. I would think they're wrong. I would debate against that and say, no, just put all your stuff in one class. It doesn't look too bad here. But when you're actually in your project, these would be in 2 separate files. You wouldn't easily be able to look at both of them at the same time. You got to split your screen, have 2 files up. It'd be a pain. More likely, the argument I would make would be whatever benefit we would get from this is diminished by the fact that we have to study inheritance. Like I have to learn what extends mean. I have to learn what a super constructor call is. It's not worth it being able to separate the code like this. You would never do this. This doesn't make sense. So why? The answer is when we have multiple classes both extending the same class. When we have weapon and health potion, and we want them both to have locations in this game, we want them both to have an X and a Y location, well, we just have them both extend game item. We write this code one time, and we get that code in both of these classes. This is the power of inheritance. This is where it really pays off for us. Now, the alternative to this is cut and paste. So we can take this code, copy it, paste it into multiple other classes. We have to do a couple copy pastes here. So you got to copy the instance variables, paste, paste, copy the constructor code, paste, paste. Not the worst thing. With just 2 classes, I wouldn't even be mad at you for doing that. That'd be fine, a fine thing to do. The issue with that, where it will catch up to you when the code does get more complex, is in a few cases. One, what happens when you have to update the code? So right now it's just storing the X and Y location. But what happens when we have more complicated methods? What if you have a method that you add to the game item class that, I'm getting a little ahead of myself here, but a method that you add to the game item class that determines the distance between a player and that item, and you're copying and pasting that code in both of your classes instead of writing it in game item. And to further that, what happens when you have to update that code? That's the real danger. Cut and pasting, it's hard. We saw cut and paste errors. You can make them when you're pasting, like in your tests that we saw, and you forget to update one of the variable names. That's a pretty common mistake. Here, you're not really updating any variable names. You would cut and paste the code. You could probably do that with no issue. The issue is when you have to update that code. What happens when you have to change some code in both of these classes? It's very easy, especially when you're rapidly changing things. When you change the code in one of them and then forget to change it in the other, or have a mistake in your copy-paste because you're copy and pasting like 3 lines of a 10-line method and you just paste it wrong or something. It's easier to make mistakes there. And you're going to want to change your code. Something we haven't really talked about, not in 1.15 and not so far in 1.16, is making your code maintainable. We want to be able to write code that's easy to update easy to maintain. So when you release this game and your users say, man, it'd be really cool to have an extra feature. I'd really like to have splash damage on my weapon. We want to be able to go into our code and update that easily. We don't want to have to write that code and then copy and paste and try to remember everywhere where we pasted that code. It gets tedious. It gets bad. It gets really tough to maintain. And we have two objects here. What happens when we have hundreds of objects? I'm going to want, instead of just a weapon class, I'm going to want a sword, a bow and arrow. I'm going to want bombs. I'm going to want a couple things I shouldn't say. Other weapons. I'm going to want mana potions. There's other game items that we're going to want. And we're slowly going to build out this game to have a lot of different items in our games. And whenever I add a new item, there's one thing I want to do when I'm adding an item, when I'm sitting down writing more code to add an item to this game. I want to think about that item, and that's it. What should this new item do? I don't want to think about all of the location, rebuilding all this code, or cut and pasting all this code. I'm going to write my new item. I'm going to extend game item, have all that functionality, and then just focus on the new functionality that's different for that class, and use all the shared game item functionality that I inherit from game item. And then when I want to add new functionality, I don't go into my hundreds of classes and write code once and then cut and paste it and 99 times or hundreds of times. I'm going to write it one single time. I want my items to be able to move in this game. I write the move method one time, once. I test it once. I'm not going to write a test suite for weapon, weapon.move, for healthpotion.move. You will in task 4. I think very few of you have gotten to that one yet. But you will in task 4, just to show you how much of a pain it is, to test each item independently. Instead, we're going to test it once in the superclass, write it once in the superclass, and then just inherit that behavior in every single class that extends it. So the game item class might be hundreds of lines of code. Once this gets big and it might control all of the physics of an item and all the interactions that players can have with the item, we write it one time in this class, extend, and then just focus on what does a health potion do? Well, it increases your health. What does a weapon do? Well, it changes your damage output. I only want to write the code that's relevant to that class, specifically to that class. Makes our code much more maintainable. And that's why inheritance. So any questions on inheritance before we see it in action in a memory diagram? How would I answered that. Is Health Potions constructor use? No, I answered that. Can you extend two parent classes to the same child class? This actually came up in the other lecture too. My answer is sort of. Let me read the next one and circle back around. Can you extend one parent class to another parent class, like if you had different types of game items? Yes, and I think those questions are related, so I'm glad I read ahead. So can you extend two classes? Kind of no. So I can't say weapon extends game item and something else. I can't extend two classes like that. You can, in 3 weeks when we talk about interfaces, you can implement multiple interfaces, but that's a topic for another day. You can only extend one class directly. So why my answer is sort of is you can indirectly extend multiple classes. So if I have sword extends, wasn't that just this lecture I answered this one? If I have sword, public class sword extends weapon, and weapon extends game item, then my sword gets all the state and behavior of the weapon class, and since weapon already has all the state and behavior of the game item class, my sword will have all of the state and behavior of all three classes in addition to everything that's defined in sword. It'll have all the state and behavior of all of them. So it's not quite multiple inheritance, not the way a lot of people mention a multiple inheritance, but you can have an inheritance chain where one class extends another class, which extends another class, which extends another class, and then whatever's at the bottom of that chain, at the end of the chain, has all the same behavior of all the classes on the entire chain. Yeah. Mm-hmm. So in the chain, if you have inheritance like that, and a whole inheritance chain, how do you call the superclass constructor? In the sword class in that example, we would call the constructor of weapon. And then since weapon calls the constructor for game item, it would go up the chain through each constructor calling the next constructor. So we would have a constructor on the stack for sword, which would add a constructor on the stack for weapon, which would add a constructor on the stack for game item. Technically adds a constructor on the stack for object, which we'll talk about in a bit. And all those constructors would be called through the chain, through each constructor. So in the last constructor, you don't have to explicitly call all of the constructors, since each constructor is going to call the next one. So for test 4, we only need to test for the comparator. I'm not sure how to approach that question. Test for the comparator. I mean, I assume you don't mean for the whole homework. The whole homework, there's a huge, there's a lengthy description of all the things you have to test. I assume you mean just the comparator class, which is extended by the Bayesian rating comparator and the song title comparator. But no, you have to test each of the child comparator classes for homework 4. So for homework 4, or for task 4, the thing about testing for task 4 is you're not supposed to know inheritance by the time you do that. Obviously, you'll know some inheritance by the time you get there. But I can't, the expected deadline is Wednesday morning. This is the only lecture you would have on inheritance before you could possibly implement it for task 4. And that's just not fair to expect in less than 48 hours for you to go understand inheritance to the point where you can implement it on task 4. So task 4 assumes you don't know anything about inheritance. Task 4 content stopped last week. Last Wednesday, actually, since Friday was a debug day. So for task 4, it's written in a way that you don't have to know inheritance, you don't understand inheritance. But then when you do task 5, you'll see that we'll apply inheritance to get both of those classes. So the Bayesian rating and the song title, both those comparators will extend comparator, and movie and song will both extend rateable, but we don't know that yet in task 4. Obviously, you can read task 5. Task 5 and 6 are both released now. You can look ahead and see what's about to happen. But task 4 assumes you don't know anything about inheritance. Okay, any other questions? Okay, let's memory diagram this thing. All right, so we got a quick main method here. When we work with a class that uses inheritance, when we're actually working with the class, we don't do anything different. We're just going to say new weapon, and that's it, just like we always have. The difference is what happens behind the scenes, what happens in the memory diagram, how the code is set up. Everything else is different. So our main method looks just as it always would. We're going to create a new weapon. We're going to call a few methods on it and see what happens. There are two big things we want to watch out for in this memory diagram, and I'll wave my arms a bunch and point them out when we get to them. Don't worry. But one, just to preface everything a bit, one, the constructor calls. There's going to be 2 constructor calls to create one object. We need the super constructor call. It's going to create another frame on the stack. And also, when a method is called, where do we look for the actual definition of that method? One of these methods is defined in the weapon class, and one's defined in the game item class. How do we know which one to use and when, which class to look in, and whatnot? That's going to be fairly straightforward in this lecture because, well, there's only one method named use and one method named move, so you really can't get it wrong. But I want to show you the process because starting on Wednesday, it's going to get a little trickier when we have multiple methods with the same name written in multiple different classes. We'll have 3 classes, all with a method named use that takes a reference to a player. Assuming I can fit all that code in one slide for a memory diagram. I don't know if I'll be able to, but we'll have a lot of methods named use. In next lecture, in the question, it's going to be a much bigger question of which method gets called. All right, so let's start with the constructor. Things start off innocent enough. This is what we've been doing for quite a while, for 3 weeks now. We're going to call the weapon constructor. We're going to put the parameters on the stack inside a new stack frame. We're going to assign them the values of the arguments. This is going to be a reference to the object that's created, and we create a weapon object on the heap. We create our variable where the reference is going to be returned to with our return arrow and the name of our constructor call. If there are any questions on this, please let me know before I just leave you behind and the class just runs away without you. Let me know if you have questions about this much now. We've already had the Classes 1 quiz and interview. We've seen lots of lecture examples like this. Barring recovery opportunities, everybody's done with this quiz. So I assume that everybody's good with this much. So if that is false, I want your questions so I can help you get up to speed. Because if not, I'm moving forward. Okay, the first change that we're seeing now with inheritance is that when the weapon object is created on the heap, it gets all of the instance variables from its own class and all of the instance variables from its superclass. So when we create the weapon object on the heap, we're creating one weapon object with all of the instance variables from both classes, the class it extends and its own class. And if we did have a whole inheritance chain, it would be all the way up the chain of inheritance. We get all of the instance variables from all of the classes inside this one object. So it's tempting to say, well, we'll have a weapon object and a game item object. No, that's not the case. We're just going to have one weapon object, and it has all of the state and behavior of both classes. When the super constructor is called, just like a regular constructor when we use the keyword new, just like this, it is a stack frame. The only difference is it's not creating a new object on the heap. We don't see the keyword new. We're not creating a new object. We're calling a constructor without creating a new object. So that constructor goes on the stack. This is still a reference to the object that's being created. So this is the reference 350 in this case. And we're going to call that constructor with this, the parameters equal to the arguments, and it is its own stack frame. Then we run the code. I don't know if anybody's called me out on this one, but technically xlock and ylock do get the value 0.0, and then it's crossed out and then replaced. If you do that on a memory diagram, that's fine. You're more accurate than what I'm showing, but it's fine if you don't as well. It's a very technical thing there. I don't care if you know that or not. But we run the superclass code. Now notice that we're in, and things are going to get wonky now that we're in the realm of inheritance. We have a constructor from the game item class. We have a game item constructor, but this is referring to an object of type weapon. So we're in a constructor while we're constructing an object of a type that doesn't match the type of the constructor. This is going to be pretty common moving forward. Whenever we have inheritance, this is going to be the case where all the super constructor calls, the type of the constructor is not going to match the type of the object that's being created, which can cause some strange situations depending on what's being called inside this constructor. So for this example, it's not too much. This dot xlock, assign it. This dot ylock, assign it. The values from the stack frame. The super constructor ends, returns. It doesn't return anything. It just modifies the reference it's given, has side effects. And then run the code from the regular constructor, this dot damage. This dot damage equals damage. And that constructor returns 2, and we get OX350 in the main method, stored in weapon. Most important thing there, hopefully I mentioned it enough times, don't forget this superclass constructor call. This is the most common mistake on the inheritance quizzes, and it's the easiest one for grading purposes. It's one of them things where if I'm grading a quiz and I see a weapon constructor and no game item constructor, I don't have to look at anything else. It's a big X through. If I'm grading on paper anyway, I put a big X through it and say no. Pay attention to lecture. Try again next week. Yeah.
So where would we, if the superclass constructor has no parameters and there's no superclass method in the child class, where would we place the stack frame for the super method?
So it would be in the same spot. So the question is, if the call is implicit, it would still be right here. It would be the first line of the constructor. So it has to be the very first thing that happens, or else Java's going to yell at me. It's going to say the superclass constructor call has to be the very first thing. If I can get the error message up here. Well, I confused it, but it has to be the very first line. So if there's no explicit superconstructor call, that's the very first thing that happens, and you put the stack frame in the same place as we have it here. I don't think we're going to get that tricky on the quizzes. Maybe Paul will try to throw that curveball out there, but I don't think he will. And if he runs it by me, I'll say, no, don't do that. This is the most common mistake, though. Most of what else is happening here, and this is, similar difficulty as you're going to see on your quiz. Maybe a little more, maybe even we can't really do much less than this. But a little more because we'll incorporate Wednesday and Friday's topics as well. But most of this is just classes, objects, references, stuff we've done before. We've already done it on Classes 1 quiz. So most of this, we just assume that you already know. If you missed the superclass constructor call, which is one of the only things that we're testing you on, the new thing that we're testing you on the quiz next week, that's a pretty big mistake. That shows that you haven't learned anything since Classes 1 if you're missing the inheritance stuff. The superclass constructor call and getting the instance variables from the superclass, those are really the two big new things, aside from the next thing we'll talk about, which is calling the right method, and then especially when it comes to overrides. There's only a few handful of things we're testing you on the next quiz. So missing this superconstructor call, it's a common mistake. It's, I'd say, even a decently easy mistake to make, but it is a critical mistake. Unfortunately, we do just have to say try again next week if you make that mistake, because it's really fundamental. If the superclass constructor call is explicit like this, which it should be on all the quizzes, it's hard to make that mistake as well. In Scala, it was a lot easier to make that mistake because Scala just worked off of magic and you just had to remember how everything worked. Java's a lot more straightforward, which is why we switched to Java. All right, so when we call a method, what method is called? So I've done this every time we made a method call. I did this the same way we're going to do it here to hopefully get us ready for this one. But let's go through that process and see it now that's going to be more important, especially when we get to polymorphism and when we get to overrides on Wednesday. This will be very important, how to look for the method call. So weapon.use, what method do we use? Well, we're going to look at the type of the calling object. So weapon.use, we're calling it from this object. We look at the type of the object that's calling the method, and we go to that class and look for the method that we're looking for. So we're looking for use. We find it right here in weapon, which matches the type of the object. So we're going to call this method right here. We are looking, again, this next line will be way more important when we talk about polymorphism, but it goes by the type of the object, not the type of the variable. For now, those will match almost all the time, except our comparators next week. But the type of the object controls which method is being called. So we're going to call this method right here the regular method call. It's going to print to the screen. I got not much to say about the actual method call itself. And then we get to move, and we're going to do the same thing. We're going to say weapon.move. We're going to call move from an object of type weapon. So we're going to go to the weapon class. We're going to look around and say, oh, crap, I don't have a method named move. What do we do? Well, we're going to go to the extends. We're going to go to the superclass, go to game item, and continue our search here. We're going to find move, and then we're going to call this method in the superclass. But the order is important. We always start in the class matching the type of the object. If we don't find the method, then we go to the superclass. Now again, in this example, there's only one method named move, there's only one method named use, but when there's a method named move in both game item and weapon, that's when we really have to get the order down when we look for the method. In that case, we would use the move method in the weapon class if it existed, and we would never look at this method unless we call it through super, which again is something we'll see Wednesday. Okay, if the superclass constructor takes no params and it's an implicit call, you do the same thing. You still put the stack frame in your memory diagram, and that happens before any code in the constructor, the child class constructor, is executed. Are xlock and ylock under weapon in the heap instance variables of the superclass? Yes. So weapon inherited these variables from the superclass, so they are effectively part of the weapon class. It's the same as typing them right here, well, with some caveats. But on our memory diagram, they go in the weapon object because we inherited them from game item. We execute the code. I don't have much to say about this. This dot xlock plus equals, update our variables. Stack frame ends, program ends. Any other questions about the memory diagram? Oh, that's not a question. I want a question. What value would be in our superclass constructor what value would be in the superclass constructor on the memory diagram if it takes no parameters? Oh, I see what you're saying now. It would just be this. It would just be the reference this. So if game item took no parameters, it would just be this, and that's it. It would look like this use stack frame. It would be the same thing. All right, I got a couple more slides. I got one little bonus topic. I have to post a memory diagram here. So object is a special class in Java where if you don't extend